inside the world's largest airplane factory. The creation of a Boeing 787 Dreamliner is a carefully choreographed process that blends advanced automation, human craftsmanship, and decades of aerospace expertise into one of the most complex manufacturing efforts on Earth. The Dreamliner, valued at roughly $400 million, depending on configuration, is not built in a single place from start to finish, but comes together through a global production system that feeds into massive final assembly lines. Most famously in Everett, Washington, and North Charleston, South Carolina. From the moment raw materials are shaped into components to the instant the completed aircraft lifts off for its first test flight, every step is governed by precision, safety, and efficiency at a scale few industries can match. The journey begins long before parts arrive at the final factory. Unlike older aircraft that relied heavily on aluminum, the Boeing 787 is composed of about 50% composite materials, primarily carbon fiber reinforced plastic. These composites are lighter, stronger, and more resistant to fatigue and corrosion, allowing the Dreamliner to fly farther while consuming less fuel. Specialized suppliers around the world manufacture major sections of the aircraft, including the wings, fuselage, barrels, horizontal stabilizers, and vertical tail. Carbon fiber sheets are laid into molds by automated fiber placement machines, which follow computer-controlled paths to ensure exact orientation and thickness. The layered material is then cured in massive autoclaves under high heat and pressure, forming rigid, lightweight structures that meet extremely strict tolerances. Once these major components are completed, they are transported to the final assembly factory using a unique logistics system. Boeing developed the Dreamlifter, a heavily modified 747 with an oversized cargo hold, specifically to carry the enormous fuselage sections and wings. These parts are flown in from Japan, Italy, and other manufacturing hubs, highlighting the global nature of the program. When the components arrive at the factory, they are unloaded and staged in carefully organized areas, ready to enter the assembly line. The factory itself is vast, with ceilings high enough to accommodate fully assembled aircraft and floor space measured in millions of square feet, allowing multiple jets to be built simultaneously. Final assembly begins with joining the fuselage sections, a process that resembles snapping together giant precision-engineered cylinders. The 787 uses a barrel-style fuselage design, meaning each section is manufactured as a single piece rather than being assembled from thousands of smaller panels. This reduces the number of fasteners required and improves structural integrity. Automated systems and laser-guided alignment tools position the sections with extreme accuracy before they are permanently joined. Workers then install systems that run throughout the fuselage, including electrical wiring, hydraulic lines, and environmental control ducts, transforming the empty shell into a functional aircraft body. One of the most visually striking stages of the process is wing installation. The Dreamliner's wings are among the most advanced ever built, featuring a high aspect ratio and flexible composite structure that allows them to bend dramatically during flight without damage. Each wing is transported into position and attached to the fuselage using massive fittings and precision bolts. The connection points are engineered to handle enormous stresses, as the wings must support the aircraft's weight during takeoff and withstand turbulence at cruising altitude. Once attached, the wings give the aircraft its unmistakable sleek profile and signal a major milestone in the build. As assembly continues, teams install the landing gear, which is designed to absorb the tremendous forces generated during takeoff and landing. The main landing gear alone can weigh several tons and includes complex shock-absorbing systems, brakes, and steering mechanisms. Engines are not installed until later in the process, but their mounting pylons and support systems are integrated early on. Throughout this stage, quality inspectors continuously check measurements, fasteners, and system installations, ensuring that every component meets regulatory and safety standards. Inside the cabin, the aircraft begins to resemble the passenger experience it will eventually offer. The Dreamliner is known for its larger windows, higher cabin humidity, and lower cabin altitude, all designed to reduce passenger fatigue on long flights. Insulation, Floor panels and sidewalls are installed, followed by galleys, lavatories, and seating tracks. Although the interior layout can vary widely depending on airline specifications, the underlying systems for lighting, air circulation, and in-flight entertainment are standardized and rigorously tested. Advanced LED lighting systems capable of simulating sunrise, sunset, and different moods are installed to improve comfort and help manage jet lag. One of the defining features of the Boeing 787 is its advanced electrical system. Unlike traditional aircraft that rely heavily on pneumatic systems, the Dreamliner uses electricity to power many functions, including cabin pressurization and wing dicing. This more electric architecture improves efficiency but also requires extensive wiring and sophisticated power management systems. Thousands of miles of wiring are routed through the aircraft, connected to sensors, computers, and control units that monitor every aspect of flight. Software integration is critical at this stage, as the aircraft's onboard computers must communicate seamlessly to ensure safe operation. When the physical assembly is largely complete, the aircraft enters a phase known as systems testing and functional checks. Engineers power up the plane for the first time, verifying that electrical, hydraulic, and avionics systems operate as intended. Control surfaces, such as flaps, ailerons, and rudders, are moved through their full range of motion, and landing gear is extended and retracted. Fuel systems are tested for leaks and proper flow, while environmental systems are checked to ensure they maintain correct pressure and temperature. Any discrepancies are documented and corrected before the aircraft can proceed further. The aircraft then moves to the paint hangar, another enormous facility designed to accommodate a full-size wide-body jet. Painting is not merely cosmetic. The coatings protect the aircraft from corrosion and environmental damage while also contributing to aerodynamic efficiency. The process begins with thorough cleaning and surface preparation, followed by the application of primer and the airline's chosen livery. Each layer is applied with precision to maintain uniform thickness and weight, as even small variations can affect performance. Once painted, the aircraft undergoes curing and inspection before returning to the assembly area. Engine installation marks another major milestone. The Boeing 787 is powered by either General Electric (GEnx) or Rolls-Royce Trent 1000 engines, both designed for high efficiency and low emissions. Each engine is lifted into place using specialized cranes and attached to the wing pylons. Engineers connect fuel lines, electrical systems, and control interfaces, ensuring that the engines can communicate with the aircraft's computers. After installation, the engines are tested on the ground, including low-power and high-power runs, to verify performance and reliability. Before delivery, the Dreamliner must complete a series of ground and flight tests. Taxi tests are conducted to evaluate braking, steering, and acceleration, while high-speed runs simulate takeoff conditions. The first flight is a critical moment, with test pilots and engineers on board to monitor systems and handling characteristics. During these flights, the aircraft is pushed through a wide range of conditions, including steep climbs, sharp turns, and simulated system failures, to demonstrate compliance with certification requirements. Data collected during these tests is analyzed in detail, and any necessary adjustments are made. Once the aircraft has successfully completed all testing and inspections, it is prepared for delivery to the customer. Final touches include installing airline-specific branding, loading software configurations, and performing a detailed interior cleaning. Representatives from the airline conduct their own inspections and acceptance flights, confirming that the aircraft meets their expectations and contractual requirements. When the keys are officially handed over, the Dreamliner embarks on its first operational journey, ready to carry passengers across continents and oceans.